Hello and welcome to everybody. That today we are going to doing modeling of one building, and we are doing the structure analysis of the building in ETABS. ETABS is a very useful software to doing the modeling analysis and design of building structures. So today is a very important critical use of ETABS, and mostly it depend on the codes and structure types and also the locality, because normally nowadays we are going to doing the analysis on base of the earthquake, considering the earthquake factor, and it's very major and significant factor in zone 3, zone 2 and zone 4. Zone 1 normally this factor is not considered. So in we are doing building code of Pakistan UBC 97, which is already incorporated. So based on that, we have to go through that building codes and codes uh, to understand the geometry, the requirement, the inputs of this software. So keep with us, and we will try to cover all the practical uses. And you need to do your research in this software and also the codes, and your situation may be different, and maybe your locality be different, and purpose of the building may be different, so your code application will be different. So code is necessary to first of all, modeling is a very necessary, very basic, and you need to do your a fine modeling for a fine results and accurate results, because software garbage in while garbage out, the result will be not good and you have to problem while modeling. But if you are practice and practice again on this one, so you will be very good in this revisiting to correct your model if you found at any stage there is a problem. So this is a very highly recommended software for the researchers, for any beginners, for the for structure engineers especially. It's a very useful tool. So today we have one building. We have to do the structural analysis of that building to check. First of all, your architect will provide you like this plans and dimensions, restrictions. So you need to check that restrictions, requirements, providing columns, beams. Normally we are doing a frame structure. In our case we have frame structure, and we have to provide columns, not too much columns at one side, like here a lot of column in this side and a lot of column in this side, and there is not a intensity of column is less at this side. It will be not good because the disturbance of rigidity. So first of all, I need to define the grids, because at x-axis I consider 1, 2, 3, and from y direction I have A, B, C, alphabetic order and numeric order. So I need to locate my beam frame structure, beam and column. That I will define my grid on base of the application of column. If there is some column or located here, I will draw my frame here. So let's see how we draw the grid in ETABS, because in this plan we have 1, 2, 3, 4, 5, 6, 7, 8 grids in x direction, and up to j, a, b, c, d, e, f, j. Up to j we have y direction grids. So let me start the grids. Normally the grids are not uniform spacing, sometimes 4 at x direction, sometimes here is 4, 3 at different. So let's go and start with our ETAB modeling. Press new modeling here. and you can press this one as US custom metric SI system because I am working SI system. Because still we are not doing still RCC, so keep as it is. I am using this one 1890, ACI code 1890, design code ACI American Concrete Institute, this one, and steel code keep as it is. Okay. When you are pressing OK, the first dialog box is open here, asking about grid dimension, spacing, number of x direction grid to actually you can visit here. So how much I have 8 number in x direction. Just I will click here 8 direction. So then up to J, let's 1 2 3 4 5 5, okay, 5 6 7 no need, actually this is for the other side. 1 2 3 4 5 6 7 8, how much? 8 in y direction. And then spacing in x direction I will keep as 4 because 4 number are more in number, and I will also keep 4 meter because 4 is more in number. How much story we have? Number of story I will as 3 because I keep basement as a story. Yani it means that we are providing the stem column as a story, so I keep 3. Typical story height, how much typical story height? 3.1 I will keep. Bottom story 3.1, actually kitni 3.1 I considered, it's not a big problem. And you can press here grid labels. I just create here a beginning with a, no, I will put as 1 and I will keep as from here. Label top to bottom, top to bottom, okay, bottom to top, no, not top to bottom, okay, because you can see that it's only ABC from top to bottom. So just click here and other settings no need, just grid only because we are going to define our beam and column. Just click OK. Here are you have 2 windows, 3 windows actually. Model Explorer, Plan, 3D. If you are very from basic, you can see your 3D here. If you are clicking here, this window will be active, and you are press here 3D, it will show you 3D. If you press plan, it will show you plan. If you click here, it means your window, this window is now active. When you are pressing this one, it will act as this one. So if you are very efficient, accurate in modeling, and you are quick in modeling, it means analysis will also take very less time. So you need to keep a grip on your modeling again and again. No need to restrict yourself in this all these given icons, confusing yourself. This is only, a lot of things are in every software is available, but practical use and learning is different thing. You are if in a professional sites, and then you only learn what you need, not you need to learn A to Z. You need to, if your working is from A to D, it's okay, you will go with A to D. If you are learning from A to Y, you can go A to Y, not X, Y, Z. Okay, only confine yourself with your practical work. So this software have a lot of icons, a lot of different tools. So choose that one which is your requirement. So it will increase your working style, your efficiency, your requirement. So that's my just advice to you people. So first of all, now we have come with the grids. Then we need to check the grid modification. Here we have 3 story, but actually we have 2 story. So let me decide this first story because this is my stem column. I will keep it 1.2 meter. Just click OK. Okay. Now you need to click here. This window, 3D window. I want to check the elevation. Which grid you want to check, it's up to you. I just click grid 1 and I want to check OK. So grid 1, here you can see actually I have this one, this ground floor, this is my foundation level, and this is my first floor level, and this is the roof. Okay, so just here you go up and down your arrows. From this arrows move down, move up, so you can use this arrow. Now you need to modify your grid based on your this layout. This layout we call is architect layout or initial layout, or we can say that this is our drafting initial draft, because this draft need to prove that this draft is this size of beams, this size of column is okay. If that is oversize or undersize, this is the main purpose of the structural analysis. Okay, so first of all we need to identify our columns, where our column located, and on that column whether we need a beam or not. Some columns are located like this is this is general store. Here general store is a for storage purpose. So if there is a drop beam or if provided that it's not a big problem. If this is a lounge or some bedroom, so if drop beam is
Ceiling inside.
drop beam, sometimes we avoid drop beam if we have come with the ceiling, because ceiling is only provide where is your height is headroom height is high, more. So that case, so let us focus on our software learning. So just click here your ETM, and then you need to check your that this one 3 4 4. You can check your grid and the x direction 3 4 4, then 3.4. okay, then 3.4. First grid you have 3. So let us start with the grid modification. Here you can modify your grid
Step by step.
yes.
Oh, very lengthy.
Not too much lunch, it will take 1 hour. I think it will be finished. So if you are providing x direction, so it will keep as 3, just 3, and press OK. OK. You check this become 3. So you need to that other is 3.4, grid 4 to 5 is 3.4. So let us pause the video and we will do this same practice with 4 to 5 is 3.4. So just I will do and I keep 3 4 to 5. Display grid data as a spacing. Okay, first click, you need to click this one. So you can 3 4 to 4 to 5 3.4. okay, 3.4. So let's pause the video and we will do the practice for the rest of our inputs or the other grids. So we have done with our grid modification.
Is put in
Yes.
software.
Already we have modified the grids as per our layout requirement. So from A to I already we have the required grid spacing, very important because we are providing the columns at these points. These are the grids, and we will show you the right clicking. Here are we have many options. Modify gridding, we already showed you how to use these tools and these commands. Now we have glue grids and the other uses. Already I told you a lot of set grid system visibility, so you can off your grid but you can on your grids. So there are log grid edit modification, show selected objects, and invert visibility of the objects, show all objects, and you have a lot of option. Your grid is now not visible. So set grid modification, just click on the set grid system visibility. When you are providing your beam column and frame section, you can off this one, grid system visibility. So you can check whether this grid is your beam column is requirement but you did not apply, so that will be show you the check. So this is your project information, design, explorer, grouping. A lot of things are there in the explorer, but we don't use the explorer. So main thing in the RCC frame structure, you have to provide this step. This step will be used frequently in our upcoming commands input. So material properties, because in this material properties we are going to provide the detail of the material which we are going to be used in this frame structure, in this real projects. So this is two type of materials, concrete and reinforcement, because we are doing RCC frame structure, and we are this is our section properties, and we have providing three type of sections. One is a frame structure, we have beam and column. We need to provide the size and spacing and material type in that sections, and then we have provided the slab section, because ETABS is not good and enough to design. You are not a sole designer of slab. Only we are provide design slabs using to apply our loads, floor loads, dead loads, because slab have a significant dead load itself, and we can export that slab to the safe for design, or we can use our stress and steel area by putting in Excel sheets. So that slab design is not a quite it's a very difficult, because we have sheets and we have coefficient methods, many methods, finite element methods even, and coefficient methods. Then we have other our diaphragms. That slab will be act as a diaphragm to transfer the vertical loads, horizontal beams as a one body. And then we have we have the functions of response spectrum, time and history. So we will use response spectrum for our dynamic analysis, if the case may be. Then we have the mass source, because that mass will contribute during the dynamic analysis to the earthquake. And we have load patterns. Load patterns will show you the dead load, live load, earthquake load, and another load, other type of load. Then we have load cases. That load case will be static, dynamic. So we need to identify that load case. Without load case, we cannot proceed our analysis. Then we have the load combinations. So we will use the different combinations depend on our type of frame. For steel frame, we have different type of combinations as per our given codes. So all these topics will be covered in this series of tutorial. So keep touch with us and try to uh, understand this one, and on your uh, locality codes, on your building codes are using in your region. So focus on that one and do research. Every product projects are have different unique features and unique inputs. So do research. Always I recommend you do research, and not like a copybook or copying one project. So from your prospect you can do your research. Then we have normally these are tools using for the modelings, that are for the modeling of loads, modeling of loads and properties. This is for the selection drawing. So these are a sample tools, not a big deal. Then you have selection, you have lot of during your modeling. This tool is very good because you are sometime revising your beams, columns, sometime over stress or under stress, whatever, after the checks and results you use that one. And then analysis tool, we have analysis. Here you can check your model, then run analysis, automatic meshing, whatever you can do the meshing, these run analysis. Then displaying, after analysis you have display many commands, we will use that one. Then you have the steel frame design, concrete frame design. Then you have the detailing option. If you rely on the ETABS setting for detailing, it's good, no problem. If you are doing yourself, you already have the drafting standards, and so you can use your drafting after the getting these results. So these are many options, we will use that options. But I, from the beginning I told you that focus on what you have required in this project.
Yes.
So thank you. So we are going to define our first I already uh, I have with the beam and column size already. So let me check the size of column, depth or width of the columns. So I have already, as per the architect requirement, I have with the the size of column. I have three type of beams, so I will use that one. I will define that beams. Then I have come with that columns. I have the size of columns. I have three type of columns also. So let me simplify that one. First, come out with the two or three types, not more than three types. While you are designing a simple build for your understanding. So first of all,
Yes.
I will define one column. Then I will pause the video for recording, and we will go. So first we need to define our material properties. Just go and material properties. Here we have concrete material. If you are already material, you can modify that material concrete. So if you want to define different, so I will use concrete class. I will that class is going to be used is C20 concrete. C20 concrete.
Okay, I will come.
C20 concrete. Okay. So commercial during all foundation and all other layers. So we are going to use C20 concrete for foundation and C28 concrete for other structures. So let me C20 concrete. Here is already megapascals. 20 concrete. You can put 28 here, but as it is, okay. So time dependent properties, isotopic factor, current time dependent. Okay, as it is, you keep as it is. slab program default based on concrete slab design code. Okay, then you have concrete rebar. I am going to modify that rebar. Here is a rebar. I keep is this one grade 60, grade 60, and here you are going to be, this is kilonewton. Okay, this is okay, grade kg, kilonewton, 7850 normally, so it's okay, not a big problem. You are going to modify grade 60. Okay, grade 60, G60, rebar uniaxial 420. Okay, so grade 60. I have come out with the, after definition of the material property. Now the next step, we are going to define our frame structure. As you know, this all are, I am going to delete all these, but shift will not work here. Delete multiple. Steel beam, steel, okay, concrete beam, or add new property. Click here, concrete rectangular. Just clicking here, you can say B01. So I keep the depth of the B01 is 400 and the width 300. It's my first initial trial. If the section is with my specification, with the requirement of the architect point of view or the requirement of the structure, so it's good, then you can change here. Okay, that's very good. These are the moment of inertia, whatever the properties of the section of this size. Then reinforcement. Okay, I'm going to design not this one, as you know, design M3 only beam, 25 mm, 25 mm, grade 60, grade 60. Okay, C28, C28. Okay, now after disappearing of all these bars, shows that you have defined the beam here. The frame is now will act as a beam. Okay, then you have, okay, let me, but here we have to provide, no, let me check where is that, B01, this one. I want copy, add properties. Okay, B02, and B02 I only change the depth 350. All other things are will be the same as B0. Then we have the B03. B03 copy B03 depth 250. Okay, then we have copy property B04 depth 600 and width 350. Now I will copy B01 or whatever from this one. Copy property and I will provide C0. I will name the property C01. Okay, and this C01 will be as per my 450. 450. 450. Okay, now you need to check this one into design column here. Then you have the 38 or 14. Okay, number of 3, number of longitudinal, number of longitudinal 3 size 4 इसको it keep 3 and you will keep as it is 20 or 16. It should be 12, more than 12. Longitudinal size bar I will prefer 20. Area will be automatically calculated. Confine bar 10. Okay, number of individual. Okay, now you have the column. Okay, you can check this one and you need to add a copy property. Just click here C02 and we have C02. Actually we have this column, we don't have this, we have circular column, so I keep as C03, skip C02 for time being, and I will define the C03 with 450 and 600. Add new property, circular C02. Okay, now we have concrete circular. Then we have dia of 500. Reinforcement detail we have provided column, longitudinal spacing 400, longitudinal bars, number of 8, 20. Okay, then 10. Okay, longitudinal grade 60. Okay, then we have defined the circular column C02. Okay, now we come out with our column and beams. Now we have remaining with the define bar with slab. So in our case we have the slab thickness 150 mm. So I will go and modify slab S01 28 grade 60 thin shell thin 150 modifier 150. Now all these definitions are need to apply on our this required given grid where required. So we are using this draw menu. From here we can draw this, or we can use this one from draw. So normally at the left side already we have this draw toolbar, so we can use that one. Otherwise we can use this as a tool. If someone have this one, so he can use this one, or he can play like a a clicking here and bringing these tools under your, like here you can draw, you can on off edit. Select, like I am going to edit this one. Again I am going to snap. I use this one, view customize. Let me customize this one. So edit already I have this one. Design I am going to off. Standard I don't use. Let me check which are the standard. Standard I am going to off. Design off. Define already I am going to off. Assigned frame, assigned joint I am going to off. Select I am select need. So draw select, okay. So you have very simple your interface to using this software. Let's take a break and then we will resume our lecture from